right, we're going to go ahead and do 8.9.2 geometry. I think this is actually in semester 1. I just know the numbers are a little bit off. Yeah, semester 1. All right, so this is, and let me see if I can zoom this in a little bit. All right, cool. So we're doing some area and perimeter. Obviously, area is what is inside of a shape. So area is just the amount of space it takes up, and that's all internal. And then perimeter is just the distance around. So think about if you have your house in your yard, and you have a fenced in yard. The perimeter is the fence line, and then the area is everything in between. So here we go. Ooh. So for this problem here, we want to find the perimeter. Remember, perimeter is just everything along the fence line. So I'm just going to add all these numbers up. Same thing here. I'm just adding all these numbers up. I thought that was going to help me work. And this one, I'm just going to add everything up. These are straightforward. I'm not going to bother doing them. You're just adding them all up and getting your answer, whatever that may be. Straightforward. All right, so find the area of the figure. So the area of a regular polygon. So area of a regular polygon is equal to A equals 1/2 PA. So I'm going to come down here. Area equals 1/2 capital P times A. And I'm going to go ahead and take that down to 1 point here. All right, so the P is your perimeter. All right, so what we want to find is what our capital P is. And I'm telling you that the capital P stands for perimeter. Now we have a regular polygon. They tell us that this side length is 5, but it doesn't tell us the other ones. Well, what regular means is that all side lengths are the same. So if you see the word regular in front of a shape, that means all these side lengths are 5. They're all going to be the same. So we go and add that up. 5, 10, 15, 20, 25. So my perimeter of this shape is 25. Little a is the apothem. What is the apothem? The apothem is a perpendicular bisector. It starts at the center of the shape and drops down at a perpendicular, so at 90 degrees. So in this case, my apothem is 3.44. So my area of this regular pentagon, sound like my son, equals 1/2 times the perimeter, which we calculated to be 25, times the apothem, which was given to us. And I'm just going to plug that into the calculator. So 0.5 times 25 times 3.44. And it gives me an answer of 43. And we should put square. If I can get, there we go, square units. All right, so 43 square units. So we're going to do the hexagon, and regular means all the side lengths are the same. We're going to use the same formula. We need to identify the perimeter. So the perimeter is going to be 12, and there's 1, 2, 3, 4, 5, 6. It's going to be 12 times 6, right? Because there's 6 sides. We do 12 plus 12 plus 12 6 times, or do just do 12 times 6. And I get 72. So that's my perimeter. And then my apothem is 10.39. All right. So that's all we had to do here. And then you could just plug this into a calculator and get your answer. All right, so regular hexagon, same formula. Area is equal to 1/2. Well, we need to find what my perimeter is. Well, 3.5. And we have 1, 2, 3, 4, 5, 6, right? Hexagon. So we go ahead and we calculate my perimeter is going to be 21. Again, it gives us the apothem. So now you would just need to plug this piece into a calculator to get your actual area. It's pretty straightforward, pretty good. All right, now down here, these are irregular shapes, right? So they're not all equal, they're not all consistent. So what we want to do is what we can do a couple different things. Is we want to divide these up. So what I could do is I could take from this corner down, divide down here, divide down here. What I would have 3 rectangles. And I'll calculate the area of each individual rectangle and add them together. The easier way, and the only reason I explained the first one was just to show you that there are multiple ways you could. So just because you don't see things the way I see it, doesn't mean that your way is wrong. So what I'm going to do though is I'm going to cut right here. right there. So what I have is I have a 4 by 4 square. So the area of this square is 16. And we have this rectangle is 12 by 8. The area of this is 96. Then I'm just going to do 96 plus 16, and that's going to equal 112, and we'll have square units. So for an irregular shape, we're going to want to divide the information that we're given. There we go. So now for this shape, we have a couple different options. This one isn't perfectly cut, so we're going to have to look at it a different way. I'm going to cut here. Cut here. So I have this rectangle, 8 times 6 is going to be 48. I'm going to find the area of this second, which is 8 times 7, which is going to be 56, I believe. And then we have this rectangle. So we need to find, so obviously we have a 31 up here and a 16 down here. So which one is the accurate number? Well, you have to look at the context of the problem a little bit here. This 31 is actually talking about this entire side, right, the long way, so it includes the entire shape. This 16 is only from the spot that we cut to the other spot we cut. So 16, and I'm going to go ahead and take this one off. So 16 is correct here. These are both going to be 16. Now, from the sides, here we have 6. From here to here is 6, and then from here to here, well, that relates to over here. That's 8. So we have 6 and 8. That's 14. Then here we have 8, and then we have 6. Right, this carries over that same distance. 8 and 6, again 14. So this gives me this rectangle is a 16 by 14, and then I calculate this area, be 224. All right, so I got 3 pieces, so I need to add them all up. And that is, and I just add them up, and that's my area of the shape. So regular polygons, we have just a general formula. If they're irregular, we may need to divide it a little bit. Down here, all right, so this one has a little corner notched out. How do we want to look at this? If I'm going to do it my way, I'll cut right across here. So that gives me 1, which is 1 by 15. All right, and then I'm going to cut right there. So another 3-fer. So this bottom one's going to be 15. So 15 times 1. Then up here we have a 2 times 6. All right, so 2 here, 6 there. And then here. All right, so this side, this 8, well, this cut goes right here. That's good. But we see we stop. This is a little bit further. This 8's a little bit too big. Well, we cut off a 1 down here. So we cut off 1 unit. So this is going to be a 7. For our purposes, this is going to be a 7. Then coming across, going all the way across is 15, except we have this 1 that we missed. So this is actually a 16, and we can confirm it up top. We have a 10. And then a 6. So that's going to be a 16. So this is a 7 times a 16. And I'm just going to go ahead and do that area. And just do the multiplication. It'll be 112. And I have my 3 pieces. So the idea of this is you just kind of want to divide. And again, we could have divided it this way, divided that way. You can kind of cut it and slice it and dice it as long as you want. But you just need to make sure that you confirm that the numbers are correct. Again, this 8 wasn't an 8 for our purposes because we cut off this 1. So we had to cut off 1, change it down to a 7. This side length here for this middle rectangle, we'll have a 10 from there and a 16 from there. Well, we can match that. We had a 15, but we stopped. We need to go the extra 1 unit, makes it the 16 as well. Here, again, there's probably a couple different ways we could do this. I'm going to go ahead and cut right here and right there. Actually, no, I did that wrong. Oh, I guess again, there's nothing really wrong about it. It's just there's a better way. I'm going to cut here and cut here. So I have a 6 and a 7. I have a 5 and a 6. Then here's 4. That's accurate. Then we need to go 9 and a 7. So 9 and a 7 is going to be 16. So we're going to have a 4 times 16. That's going to be 64 right there. And then we would just add 42, 64, and 30 up. So for the irregular shapes, we just need to basically break them apart as individual rectangles or squares and multiply them and then add them together. That's it for this section. So for the irregular ones, we need to basically just slice them up. Think of it, you're at your house. This is a floor plan of a house. If you want to get your square footage for your house, is you can't just unfortunately do length times width, a simple area, because your house is going to have different kind of nooks and crannies, different room layouts, and you're going to need to go ahead and get the area of each individual room, the other room, and then you add them all up, and that'll give you your square footage of your entire house. So the irregular shapes, we are looking at breaking them apart and getting individual and adding them up. And then for regular polygons, we have the option, well, not the option, what we should be doing is using the formula area equals 1/2 times perimeter times apothem. Remember, a regular polygon means that all the sides are the same. So you just add them all up for the perimeter, and the apothem is this little 90-degree drop pound perpendicular. And then perimeter for irregular shape, you just add them all up. All right. Now see if I can turn this video off.